And how we doing tonight, folks? Welcome to the Wednesday night edition of the Land Timber Stream. I have been very busy. It has continued. So just like yesterday, the last few days, the last week and a half or so, it's been very little time for study, unfortunately, due to a lot I have going on, including taxes, errands to the bank, grocery store, helping out with, I'm doing more cooking now that I'm helping my wife out with getting started on keto. So yeah, needless to say, it's been interesting. But that being said, I did want to take at least a little time on stream to do something. So today, I think this is the last piece of shaping I need to do, in at least covering like the material and network lessons, and that is shaping with subinterfaces. There was a network lesson talking about mastering shaping in terms of PVCs, which it might be an old lesson. It might be for, I think it should, theoretically, we'll see, it should apply to subinterfaces as well, which would be, might be a more common implementation in today's networks, right? So yeah, I've been, I'm still behind on flashcards. Got to try to work on that some tonight if I have time. But yeah, other than that, we're going to just hit a one of these network lessons on shaping. And here's, I've kind of revised this. Again, the original network lesson is on networklessons.com if you want to check it out. So it's not like I created this lab or anything or invented it. I give credit where credit is due. And this was certainly Renee Molinar's site, networklessons.com, is awesome. If you want to see like the original lesson, original material, definitely check out that site. And of course, it's a subscription service, which you could do by the month. You get a 7-day free trial. You can also do by the month or by the year, and I've done by the year and I have used it and definitely got my money's worth. So definitely check that out. But here is the basic lab we're going to attempt today. And again, this is probably the last bit of shaping that I may need to do for a while. I'll feel like it's probably been covered, basically, when this lab is done. We'll get, again, even harder into policing. But the physical rate, just imagine we have an interface and real simple setup here. Already have the lab open. Let's say no. We're just booting up a couple of routers from scratch. Router 1, router 2, that's it. And we can play here because this is EvenG Pro. So I can actually edit the quality and add some, I can change the rate, which I have not done that yet. What we may do, let's just imagine, for example, let's change this up from what I originally planned. So I'm going to move this, let's move this into the main screen here. And what we're going to do is we're going to say, the original idea is use the maximum, well, allow this to burst to the maximum of the physical interface. Yeah, scratch that, we're not going to do this yet. But let's say this is a gigabit interface, right? And we have two sub-interfaces here. We're going to have GI001 and GI002 on each side. And what we want to do is they're going to have different CIRs. So sub 1, we'll just say, let's see, GI00.1, and we'll have a CIR of 500 megabits per second. And 2 will have a CIR of 250 megabits per second. Each subinterface, these are requirements. Each subinterface must be shaped to the CIR, but it should be able to burst up to the physical interface rate. And in this particular case, our TC is 50 milliseconds. Why would you select 50 milliseconds? I don't know all generally Cisco recommends you let them choose the TC, which what we have seen, at least in iOS V, is often goes to the minimum, which is 4. Which is fine. But yeah, I've also seen some documentation say, like, I guess it's applicable to the older iOS code would default generally 125 millisecond. You can shape it though with your own TC, and this is often done, from what I've read, based on the traffic types that you might have. So for example, you wouldn't want too long of an interval to pass before, while traffic is buffered, because what you're doing, shaping, of course, is going to introduce some degradation of service. Every QoS tool that you implement, effectively you are improving the quality of one service or multiple services while degrading the quality of other services. You're trading off, right? That's essentially what QoS is. No matter what you do, something is going to be impacted by your change, right? In most cases. So in this case, for example, 50 milliseconds, that is a longer delay than 4 milliseconds while traffic might be buffered and other traffic is bursted out. But the effect of that is, okay, maybe you want to have a longer TC interval because you want to ensure that there isn't a long delay between, or you would have a shorter TC interval, or traffic that is sensitive to jitter, for example, voice or video traffic. So you wouldn't want to set your TC to be too long. So that is one of the considerations that is made. And again, I don't know all the considerations. Like I said, Cisco generally recommends you not to tweak the TC size. So, but we are going to do that in this case. So our formula here, if we want to calculate the bursts, and the way I have to think about this is based on what I learned from this lesson, is when you have 1 gigabit per second, and you're going to do, I assume that we're going to do shape average here. So instead of peak. So it's, to me, in my mind, it's simpler to figure out that way. It's simpler and therefore probably more sublime and superior. So at least for me to, if this is my network, if I know better how to troubleshoot shape averaging, then that's what I should do, right? If I don't fully understand what the differences are with shape peak configuration, then it's probably best I go with, what is known, what will get the job done, and is sufficient to get the job done. So in this case, we'll go with shape averaging, which means we're going to use we're only going to refill the BC bucket at every TC interval with the BC bits. But if we wanted to be able to burst up to the interface, the physical interface rate, which is interesting because, to be honest, again, when we think about how packets are transmitted, that's not what this is, right? Because when the router transmits data onto the line or the physical interface, it's not going to slowly trickle out the data. It is always going to burst and transmit at the maximum speed. Well, what this means, burst to the physical interface rate, is that within 1 TC, we could theoretically burst up to 1 gigabit of data. So the BC in this case would be, oh, sorry, I erased my formula here, didn't I? No. So what we have to do is say, all right, if the BC is this many bits, we have to subtract that from the interface BC, or the interface rate, to get the BE. So interface rate, the max rage, yeah, we'll see some rage probably, is going to equal BC plus BE. I would say, let's do it like this actually. Max BE rate equals interface rate minus BC. That's not an exact formula, but anyway, if you want to get the largest burst size available, then you need to take the interface physical rate and subtract the BC rate from that. So first we figure out the BC rate with our formula, BC equals CR times TC divided by 1,000. On the first subinterface that we're going to configure, the CR we have already been told is 500 megabits per second. So BC equals 500,000. Let me make sure I got that right. Yeah, 500,000 times 50 divided by 1,000. So let's go to our trusty calculator that it seems I already closed and tend to close so fast that so 50 divided by, we already know what that is, right? 0.05. So basically we take 500,000 times 0.05. 25,000 bits. Oops, I don't know what I just did. Some function that I would never use a calculator for, but apparently is the default. So our BC is 25,000. So what we need to do here is basically this is going to be, this is some easy math because this is double, right? If the CIR is 500 megabits per second, and in fact I need to revise this. We're raging today for some reason. That's the BC CIR. Well, the CIR. So if the BC is 500 and we want to use the rest of that capacity for the BE, then it's going to be easy. It's going to be double because 500 would be for BC. That leaves 500. The same amount. That's 25,000 bits every 50 milliseconds. All right. So now let's go over to the second subinterface. And in this case, we use our formula, BC equals, I've already got it here. So we're going to do 0.05 times 250, 123. Makes sense, half, right? BC equals 12,500 bits for every 50 milliseconds. And in this case, though, the BE CIR, we'll just call it that, is going to be 1 gigabit minus 250 megabits. So our formula in this case will be 750, 123 times 0.05. Yeah. Wait, is that right? No, I left out a 0, I think. Yeah. So that should actually be like 3 times. Is it divided by 3? Yeah. So we just wanted to go through the formulas though, get practice on that, make sure our logic is correct. So we need to now configure, let's go ahead and configure the routers. Let's put an IP on these interfaces. R1, not host. Face GI 0, 0, no shut. GI 0, 0, 1. And we're going to put an IP here, IP address 10.10.10.1. Now let's do 10.1.1.1. Oh yeah, we have to do incap.1q, and we'll do 1 here. And the interface GI 0, 0.2, incap.1q2, IP address 10.1.1.2.1. There we go. Now let's go to router 2. interface jazz 0, 0, no shut. Interface jazz 0, 0.1 dot 1q incap or incap dot 1q 1 IP address 10.1.1.2 interface jazz 0 0.2 incap dot 1q2 IP address 10.1.1.2.2. Okay, let's just make sure we can ping 10.1.2.1. We can ping 10.1.1.1. Good. Okay, so shaping configuration. Let's see if I can go, well, let's put it in here. So I'm going to say a router 1, interface jazz 0, 0.1. Well, actually, we need to do, all right, so we're going to say class map match any. And then we're going to say policy map. Actually, let's do class policy map policy any class class any, and we'll say shape average. And in this case, we want to say okay, so shape average is going to be 25000. And then the burst is the same. And how do I set the TC here? I don't remember. We're going to play with that in a second, see, and hope that this works on a subinterface. Again, I'm kind of making up my own, well, copying another lab to a different topology here, right? So in this case, we're going to say a service policy service policy output policy any. So let's see if that flies. On router 1. Hey, liked all the commands. Let me go back though. Policy map. Shape average. Target bit rate, bits per second. 25123. Okay, this is where we put our bits per interval. Excess. So we have to put, okay, I left this, this is wrong. Shape average and then the CIR. The CIR is 500 megabits per second. Bits per interval sustained. Interesting that it's recommend not to configure. Algorithm finds the best value, right? But hey, 25123, 25123. Okay, that is a correct command. Configured shape BC value results in the interval being out of range. Allowed BC value for the given CIR of 500 megabits per second should be at least. Oh, did I do the wrong? I did the wrong thing. I did kilobits. So 1, 2, 3. Yep, sorry about that, folks. Math is hard. Let's do this again. Thank you. Actually, I don't want calendar. Thank you, iOS, for a parser for actually being useful here. 500 million, which is 500 megabits per second, times 0.05. All right, that's more like it. So 2 5s Actually, I just need to add that, right? And probably the same here. Okay, let's try that again. So this is going to be, what we'll do is just take this out. Say no. No, we won't do that. Let's see if it likes. And what is this? 250. $25 million bits. Yeah. Let's do that and that. Okay, it liked it. It liked it. It likes it. So first thing is the CR. I forgot about that. 500 meg, 25 meg, 25 meg. So let's just verify that. First of all, it did allow us to configure the subinterface, which is cool. And now let's do show policy map interface jazz 0, 0.1. Okay, it is configured. Target shape rate. Yeah, it does not show us the TC here, but we're going to put this to the test. Actually, it's going to be kind of hard to do that without the iPerf set up. Excuse me. Oh, head sneeze. All right, so the next one we're going to do is the other subinterface. I should have named these better, right? But that's okay. Class. We're going to use the same class map. Policy map shape low. I will do policy shape low. Class any. Same class. We can reuse it, right? That's the MCQ, the modular configuration set. And then shape average is 250 meg. And then this will be, yeah, so obviously we're going to have a smaller, so I'm going to have to do 12512K. And then 37. Okay. And then what we'll do is interface jazz 0, 0.2, service policy output, policy shape low. Okay, so let's add this config. He likes it. Now show policy map interface jazz 0, 0.2. There it is. Can I push traffic through here? I don't think I can with this tool. I can just... I could put a loss percent. I could put a rate. Yeah, interesting. I've played with delay and jitter before, and not some of these others. So that's really it, folks. That should be our last shaping lab and study mode before I get back to the I&E workbook, which let's take a look at the old workbook. It's been a while since we've workbooks probably feel a little neglected here, and rightly so. But I'm going to log in and just look, and let's get a plan together probably for this weekend, because again, this week has just been, it's been a life week for sure. In a good way, in a good way. Bad for lab, but good otherwise. But I really hope to dig in onto some QoS labbing this weekend and knock out some labs here. So we should be able to, yeah, this is LLQ. Red, I have not hit that part yet in the I have not hit that yet in the book. ECN. I've actually saw some ECN in prod. I didn't really think it was used that much, but it is. I've seen ECN and TCP traffic in a production network that I was troubleshooting this last week. But here's our generic traffic shaping, class-based generic traffic shaping, and CBWFQ. And then we got our 1, 2, 3, 4 police labs. So we've got 2 shaping labs, 4 police labs. All we got. But maybe it's all we need, because as we're seeing, the actual configuration is a cinch. It's a cinch. Just understanding and knowing the formulas and knowing how to produce the result that is being asked for has been the challenge up until now. But anyway, thanks for stopping by, folks. Another stream is under the bridge, and always appreciate the viewers hanging out. By the way, Cisco Live coming up. I need to get my accommodations done. I have not done that part yet. I got my flight. I just need to get accommodations. And I need to work on that soon, but hopefully that will get caught up on that kind of stuff after our taxes are done. But thanks so much for hanging out and at least sharing a little bit of study time. And again, drop in the Discord. There's a Discord link here. Give us a chat in Discord, especially if you're going to Cisco Live. I'd love to meet up with you at Cisco Live and hang out and get to know each other in person. If you know, someone just told me today that they are going to make it to Cisco Live, so that's great. We will plan a meetup. Probably will happen on a Wednesday night. Maybe what we shoot for, or is that the main event? I forget. That may be the Cisco outing, so it might have to be Tuesday night, but we'll see what everybody can do. Thanks so much for hanging out. You can follow me here on not only on Twitch, but you can follow me on YouTube, Instagram, and Twitter, of course. And we shall see you back here tomorrow night, same time, same place, sending you good bits out there in the universe on your labs and your study, and wishing you the best. And we'll see you here tomorrow night here in the LAN Tamer stream.